Good morning. Ben talked about memory-constrained devices and how it's affecting your development environment. I'm going to talk about a very constrained device, slightly different than the last presentation. It's not as important as the last presentation, but let's start anyways. Okay, I'm going to talk about this device. Does anyone not know what a NES is? It stands for the Nintendo Entertainment System. Probably the coolest of all the consoles that were ever made. And because it was so cool, I thought, let's do a presentation about the NES. And then a whole world of pain. I ended up buying a cartridge on which I could write my own ROM. And I wanted to make this presentation and call it how doing a presentation cost me about $100. But I named it something else. Okay, maybe let's switch to the NES. There we go. I hope no one has like things with flickering screens. I'm sorry otherwise. It's not going to flicker after this. Okay, so my talk is called Super MarioScript Tools and Tips for NES Development. Super MarioScript is not... Disclaimer, I did not write a domain-specific language. Super MarioScript is not a real thing. I just had to come up with a title. Okay, so I'm going to talk a bit about developing for the NES. I'll talk a bit about myself. I'm Fritz. I'm not German, although my name might suggest that. The name is actually South African, which doesn't make sense. I'm not a computer scientist. I did not do anything remotely computer sciencey. I studied at an agricultural university. I did some soil erosion, some sociology. So I did not know what bit shifting and byte swapping was before I started this. I have somewhat more knowledge about that now. I do a lot of things. I am mostly a front-end developer. I do a lot of JavaScript, some server-side JavaScript, some Python, and I'm in a band. I have so many things. I do so many things. So I want to talk about three things. First thing is constraints. How you will all learn to love them. I want to talk about doing new things, and I want to show a quick demo on how you can also start building your own NES ROMs or NES games. So some fun facts about the NES. As you can see, it's a really, really limited device. It runs a 1.79 megahertz CPU. That's 1.79 megahertz, not gigahertz. And it runs a 6502 CPU. Does anyone know what a 6502 CPU is? Yes, we have some elderly people here. The 6502 CPU is a CPU architecture, just like x86 or ARM, which runs on mobile devices and Raspberry Pi. But it's an architecture that was designed in 1975. So by the time this thing came out in 1985, it was already 10 years old. So the CPU wasn't at all like a very novelty thing for this device. The CPU also contained the audio processing unit. So if you want to do something with chip music, this is a really great device. It has 4 channels of synths and some noise channels. It's really great if you want to make 8-bit music. If you want to do other stuff, don't do this. So what set the device apart wasn't the CPU, it was the picture processing unit, or the PPU. Run at a bit higher speed, but the speed is inconsequential. What really mattered was it could do scrolling. So in almost all of the NES games, you have a background and a foreground, and if you manipulate the character, the background would scroll. You know, like Super Mario Brothers, or something like that. That's what really set it apart. It could do horizontal and vertical scrolling, and that was really like a super big thing. The other thing it could do, it was, instead of manipulating pixels, it showed sprites. The sprites are images of 8 by 8 pixels on this device. And if you could combine like a few of those sprites, you would have a character like Mario. And you could, it could run, and it could change, and it could animate. That's what really set this device apart. It had 2 kilobytes of RAM. So there's that. It had a screen size of 256 by 240 on all the European and Eastern, South American, and Australian devices, the PAL devices. I don't remember if you know the PAL and NTC difference. The NTC system was a bit older, and it could only show 224 pixels, and it ran at a higher speed. So if you would run a PAL system on an NTSC device or an NTSC disk on a PAL Nintendo, it would run the music slower. Oh, whoops. The music slower and a bit lower pitched. So that is an interesting fact. It only has 64 colors. Imagine that, a device with only 64 colors. Of those 64 colors, 9 are duplicates, or 8. So 8 are duplicates, and on NTSC, it doesn't show one color very correctly, so it actually only has 56 colors. And if you have a screen in front of you, you could only show about 16 colors at a time, which is crazy. And also, it also makes it very recognizable. So if you see a color palette of any of the NES games, you can probably make out which game it is, because it is so defined by the palette. Per character or per sprite, you could only show 3 colors. So unless you were doing some extra cool thing where you overlaid sprites, you only had 3 colors per character. That's why Mario only has 3 colors. And it actually has 4 colors, but the 4th color is transparency color, so that doesn't really count. And then most things in the NES come in multiples of 8. So you only have 8 keys, the up, down, left, right, select, start, and A, B button. You only have 8 by 8 pixels. You only have 8 sprites per scan line. So the way old TVs worked was they would render all the scan lines. So line per line, it would render 50 frames a second. Pretty impressive. If you compare playing Call of Duty on an old device, you could probably not manage 50 frames per second. But 8 sprites per scan line also meant that if you had 9 sprites on one single row, so imagine you have Mario and a mushroom and a Koopa and something, it would flicker or would just fade away. So the way developers would work around that is make a sprite flicker just at the right time, so you could sort of have more things on one line, and they would cheat a bit. But that's why you sometimes see the flickering on the NES. I have a transparent cartridge, which I thought was really cool, because then you can see the 2 ROMs. It's actually not one ROM, it has a character ROM, which is 8 kilobytes of data about what the character looks like, and the program ROM, which is the program. Okay, so constraints really suck sometimes. So to do the rest of the presentation, I'm actually going to switch to my laptop, because otherwise I would only be able to show you like these colors and these images. So let's leave it at that. Where were we? Yes, constraints, fun facts. Okay, can anyone tell me what game this is from? If you guess all of these next questions correctly, you can get this little Mario. Super Mario Brothers? 2? Okay, and on which device did this run? This specific image?
Super Nintendo.
Or the GBA, yes, too much colors. Okay, and did you also know, let me just get rid of this, otherwise I have this mirror display thing. Did you also know what the original game was called that later became Super Mario 2? Doki Doki Panic. Yes, we have someone who knows. Well done. You can later pick this up, sir. So this is what it looks like on the SNES or the Game Boy Advance. Like nice colors, animation. And this is what it looks like on the NES. A bit easier because you don't have that much space, so you don't want to keep track of all these animations and colors. So the NES version was kind of simmered down. Oh, yes. So now I want to talk about why constraints rock. I really love constraints. Some beautiful constraints I use daily are Twitter. I can only use 140 characters per thing I send. If you want to make a poem, you are very limited. If you want to say something to someone, you have to be very concise. And this is a constraint that I think nobody really cares about. Sometimes people start blogging on Twitter, and I'm like, why are you using Twitter? Like 9 or 10 messages that keep on following each other. Maybe not the medium, but it's a beautiful constraint. Also, emoji. Have you ever tried to have a conversation with someone in emoji? It's kind of difficult, but it's a nice challenge for the mind. And the last one, I think most of the people here are doing programming in some form or other. Otherwise, it would be, well, you could go to a JavaScript conference, you could learn a lot. But in programming, you only have a few words that you can use for if JavaScript makes it a bit easier. Sometimes have the for each and stuff like that. But you only have like a very limited set of words which you have to make the whole world with, which I find very interesting. And it's a very interesting constraint that is very limiting, but also gives you a world of possibility. One of the most constrained games you probably have seen is the Super Mario Brothers original game. It only had the character and the program ROM. And the later games came out like Mega Man 2, which had like extra ROMs, and they did something with soldering, and they implemented extra RAM on the cartridges, and so they could do some interesting stuff. But Super Mario Brothers is the most, like, it's the cartridge I bought. It's the cheapest one to make. It's the easiest to think about. These are all the images that are used throughout the game. You only have the background and the foreground. So 8 by 8 pixels, and then 128 sprites on the whole thing for the foreground, 128 for the background. So I think that's pretty interesting. And why am I talking about constraints? Because we use and encounter constraints every day. We encounter constraints in browsers. Internet Explorer is like a huge constraint if you want to do something that's pushing the web. Or, well, you have to really think about what you're doing or what you're not doing. And also we have clients which give constraints to us, or we have to extract the constraints from them. And the better you know your constraints or the space you can work in, the better you can make something that is really creative. And sometimes we're not aware of our constraints, and we make something and we find out in production that we have been constrained by some devices. But that's why I want you to think about that. If you are interested in constraints and how they could work for you, also check out Amanda Glosson's talk. She did something in JS Fest in, I think, Oakland or something. But that's a really interesting talk. Also want to talk about doing new things. The background image, by the way, is a game that came out last year, a NES game, on a cartridge. You can actually buy it with a box and everything and a poster. It's pretty expensive. It's like $40, but it's pretty cool. It's made by someone in the JavaScript community called DustMop, who's also an avid Node developer. Which it's only on the background because it's a new thing. So doing new things is really important for anyone. I love doing new things. I do new things all the time. It's also because my brain tells me that doing new things rewards me. So it releases a bit of dopamine. It increases my plasticity, and I can think about difficult problems in a new way. So it expands my horizon. Also, your brain sort of stops growing when you are 25, but it doesn't mean that it's not plastic anymore. It's still plastic. It can still be molded. It can still be. You can still learn languages when you're 25, or when you're 40. You can still learn languages when you're 60. It will only be stored in a different place in your head than when you are 5 or 6. So doing new things, really important. Something I find very frustrating is where the not invented here syndrome. People talk about this as if it's a bad thing. Not invented here means, okay, I'm going to rewrite this JavaScript framework. I'm going to rewrite web frameworks. And people talk about it like reinventing the wheel, as if it's a bad thing. I think it's a great thing. Reinventing the wheel and not invented here. I try to make things myself all the time, failing horribly. And I'm not saying you should run these things in production. Definitely not, because there are probably way better things than you came up with by yourself. But it's really interesting to think about these problems and to try to wrap your head around what is a server, how does HTTP work, or how does a NES work. It's not so much the thing of making something that will be awesome, it's just diving into something and really getting to know it. And probably you should not run it in production. Let me just say that again. It also helps you remove abstractions. I hope this slide, yeah, the colors came out fine. Great. Unless you're colorblind, by the way, because then you can see red and green together, right? I'm sorry about that for those people. It says remove abstractions. Remove abstractions, what I mean with that is I bought a house last year, and I started remodeling with some friends, and I had hired this contractor, and also had to do things myself. And some things I really did not know how to work. So it's like, okay, a new bathroom, how does that work? You take away tiles, I guess? So for me, this was just like a black box. A new bathroom, you take out the old one, and you put in a new one. But then I had to drill away this much of cement to get to the pipes. And I'm like, oh, this is how pipes work. So it doesn't mean that now I am a plumber, because actually I busted one of my pipes and I had to run down the stairs, run into the basement and close off the water. But it did help me think about plumbing in a less abstract way. So I encourage you, do new things. It will remove abstractions for you. And if you're into this, there's also another blog post by Scott Hanselman, which is really great. He uses about the same example, so sorry for stealing that. So I, of course, thought, I'm being super original. JavaScript, Nintendo, I'm going to be the bee's knees. I'm going to be this super cool guy who wrote this first NPM module, and it's going to be a NES module. And then, of course, there's been people before me doing this in a much better way, thankfully, so I could use some of their stuff for the presentation. So if you want to do something with NES development, especially if you want to do chip music, install these modules. They're really great. So I was thinking I was being a very cool guy, and then I came across these modules, and I came across a lot of things that explained to me how this works. And I'm really thankful for that. So with that, I'm going to show you a demo. And I know this is a really bad idea. It's going to be a sort of live coding in a presentation. Let's hope it works. Okay, so I made a little GitHub repo. It's on my GitHub is Fritz with Fritz, and then VD, like venereal disease, slash RuhrJS, and you'll find a little a little JavaScript thing I made to build a NES ROM. So the repo contains a compiler, and it contains some NPM packages that can help you. I also learned about abstract syntax trees. I did not know what they were, and I thought I was going to get lost in the forest, but I didn't. But it uses falafel to read the JavaScript, and then replaces it with assembler. Assembler is fun. Okay, so I have a few scripts. Actually, in the assembler in 6502, you can't count like over 256. So if you write a for loop, and you want to do this for your background, you have to do this 4 times, otherwise it won't fill the background. This is true. So I wrote 4 scripts, so I'm just going to run the npm build the whole time so you know what I'm doing. It's going to run npm start, so it's building the JavaScript to assembly, then it's going to compile with the NES assembler, and then it will run the last thing is it will run the ROM. So the NES index.NES, this one, it will run the ROM. And the one before that, I will show in a bit. Okay, so the first demo, I showed you the the ROM I made for the cartridge. I made something similar, and now I want you to pick a color. So pick a color from the NES palette, please, someone. 2A. That sounds like a great idea. Okay, we're going to change all of the colors, all of the palettes to 2A, and I'm going to run the compiler, and you'll see that it will have changed. I will first run to show you that it will actually do something. So this is building it, and then it's compiling. Okay, it's green. Okay, now we'll change all of these colors to, thank you, Atom, to 2A. I'll run it again. And now it's light green. Hooray. So the way this works, it has a little header in the top, which is of no importance, and it's very similar to CSS. You have to reset everything before you can render stuff. And then you have a few palettes, which I just changed, and then it will show you some stuff like load sprites. It's just a function that will replace this, like an assembler function that will replace this No need to worry about that. If you want to get into hacking with this, just send me some GitHub issues or Twitter messages, and we'll get into some more stuff. So the backgrounds. By the way, does anyone know what game this is? It's super rare. If you find this game, it's like 2,000 euros. So it's Mr. Gimmick. Oh, okay. And we're going to change a bit of the background. So this is the background. It's just a bunch of numbers, all matching to background tiles. So every background tile is 8 by 8, and 261 actually is, well, 256 minus 261 minus 256 is like 5 or 6, yeah, something like that. So this is all blank numbers, these, and there's some. This is the RuhrJS logo somewhere over here, but this is really difficult to work with. So I made this, or there is a map editor, and I really like this one. I forgot to open the folder, but that's fine. Yeah, there we go. So we have a map editor, and you see the RuhrJS logo. It came out a bit weird in the ROM. I'm sorry for that. It's something with the routine that's not working. But let's put in some more logos of the RuhrJS. Go like this. And then stamp, 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 stamp. Roar, 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 roar. Save it. And then, well, this looks familiar, right? Yeah, it's the CSV data for the same background. I'm going to change it. And if all goes well, we should now see a lot of logos. And hopefully no compiler errors. Am I right? npm run build. Way! So it worked. Color is kind of strange. Thank you. I'm not sure how am I doing on time? I have like 5 minutes left, right? Okay. Yeah. So I'm not going to do the last demo. If you want to see it, I was going to switch the little guy I made. Where is it? So this little dude over here that's moving. I was going to change it with Kirby, but you can come up to me in the break and I'll show you. Okay. So what do I take away from this? I have never done C or assembler. I did not do computer science, but it's not that hard. If you start doing something and start working at it, it becomes like the first few weeks were horrible. I handed in this talk. I was like, I'm going to do this, and then I was like, oh crap, what have I gotten myself into? But it's not that hard, and especially the NES dev community, it's really strong. If you post something on their forum, within a day, someone will respond and help you out and give you an answer. And it really helped me stay with it. Otherwise, I would just quit the NES development and given another talk, I think. I don't know. But strong community draws people in. So if you're working on open source, if you're doing something and you help people out, they will stay with your project. It really works. And whenever you're somewhere in open source world, a whole new world, always lower the barrier to entry. People will thank you for it. Like, I couldn't find how to install the compiler. Like nowhere. And someone said, okay, yeah, just install the compiler and then run the compiler. I didn't know how to do that, so I wrote a blog post about that. So now someone else will not have to find out how to install the compiler. Yay, Fritz. And constraints. Constraints are lovely. You have to just learn to appreciate them. And constraints force creativity, and they will force you to think about certain things. It has certainly helped me think about constrained environments, just like Ben Schwartz was talking about, like where people don't have internet all the time. Like on the NES, you don't have internet. So, well, unless. Have you seen Rachel Codes? Do you know @PartyHexcellent? She made a connectedness. And she hooked up a Spark I/O to the Nintendo, and she now gets a Twitter feed on her Nintendo. So NESDev has really cool people. This hashtag on Twitter is really cool, but you can also just Google NESDev and you'll go to the forum and you'll find really interesting things. So I want to acknowledge all of what I did was not made possible if it wasn't for Shiru, Brad Smith, the guy who's making a new game as well, who launched the Kickstarter and will launch the game this year. Doug Fraker, who also had a C tutorial on the internet, and MK, Michael Matuzak, the guy who did the Nestle sound libs for NPM. So, thank you very much.